Okay, so detection of an unknown inorganic salt. So Asmita Sarkar is the new student. Okay, so how to detect it? So I have told earlier that first of all we have to detect the physical characteristics. So from this bottle I am taking a salt. Now the physical characteristics I can see here, this is crystalline, okay, and white in color. Now next part is that making the solution, that is preparation of OS. So OS preparation. So preparation of OS, basically these are water soluble, except water there is HCl, dilute HCl. Okay, except water, but this is not included in your syllabus. So only aqueous medium, the soluble medium is the aqueous medium. So we will try first with water. Okay, so I am taking the sample. So sample is taken in a test tube. No need to take a lots more sample. Now the second method is that they are having dry test. Okay, they are having also dry test. What is this dry test? Dry test is that first of all test it with dilute acid, that is dilute sulfuric acid, then concentrate sulfuric acid. These tests, these two tests are basically for the anion. These are called preliminary tests. So what are these tests? That is dilute H2SO4 test and concentrate H2SO4 test. So in these two tests we have to take the direct sample, that is solid sample, then we have to add the dilute acid. If any effervescence come, if any colorless gas or any pungent smelling gas are coming out, then we have to identify it. This is very important. Suppose you detected nitrate as a sample, okay, nitrate as an anion. Now in dry test they are having test, that is in dry test nitrate respond in this case when you do it, that concentrate sulfuric acid plus copper turning, then a brown fume will appear here, but this is under a dry test. So here you have to present nitrate and your conclusion is that nitrate may be present at that case, okay, and in the wet test we will confirm it. So this portion is very important because the inferences done after the wet test, it should be present on the dry tested, okay. So here applying the your condition, that is applying your idea, you will present it on the dry section, that is the dry experiment section, okay. So for the simplicity we will make solution here. Now shake it well. Shake it well. Till the total sample becomes soluble. Okay. Now the total sample is soluble here. You can see no residue left after the solution. So this is kept reserved for the further test. Okay. Now first is that test for anion. So is prepared, then test for anion. Now test for anion, first of all we will do the test for halides, that is chloride, bromide and iodide. these having 3 different color or PPTs. Then for any nitrates or acetates present, but these are also responsible in the dry tests. Okay. Next one, that is the acetate. When you make a with any base, then it will give a effervescence of acetic acid, that is vinegar. Nitrate also respond on the concentrate sulfuric acid section. They are giving concentrate sulfuric acid only. If brown vapor come, then it is for nitrite, NO2 minus. But if the brown vapor comes after the addition of copper turning, then it is for nitrate. So these are the differences. Next one is that sulfate. Here sulfide are also there. Sulfide also respond on the dry test section, sulfate and carbonate, CO3 2 minus, when dilute sulfuric acid is added to the direct sample, that is solid sample. Next one, halides and then sulfate. Okay, sulfate and phosphate is there, but phosphate is, as it is having a difficult pathway, that is ammonium molybdate solution should be used, and the phosphate also later on those who will make a higher degree on chemistry, they come to know about the interfering. What is interfering acid radical? Phosphates, these are also called interfering acid radicals. Why these are interfering? Because if it is present, then in the group separation these have to be excluded first, then you have to go through the test for anion. Okay. Now sulfate, so first of all test for halide and then for sulfate we will do. So from the original solution, any confusion? If any confusion, then tell me. Okay, let's see. Very little amount of some solution taken, very little amount. Now you know very well what we have to add, that is silver nitrate solution. Silver nitrate solution added, no PPT comes. So here these inference, that is the presence of halides etc. is absent here. Okay. So I am rejecting the solution, then we will do it. So as halides are absent here, so in the dry test section, in the concentrate sulfuric acid test, you must write that the halides are absent, that is no characteristics coloring gas, that is the greenish yellow gas or brown vapor etc. or red vapor does not evolve in that section. Okay, because these are wet test. In wet test we will confirm one radical. Next is that these are can be confirmed by dry test. Carbonates and sulfide also confirmed by dry test. Now I will move to sulfate. Okay. So test for sulfate, that is taking the OS, next adding barium chloride to it. Okay. Now barium chloride will be added here. These reagents are available on the rack. Now just see that. Okay. Just check that a Cardi white precipitate appears. Okay. So this is a confirmative test. Now to further confirm it, we have to add dilute sulfuric acid here, that if the PPT is not dissolved, then it is for sulfate. Okay. So, for this I will reduce the volume of the solution so that it makes easier. Now, dilute acid. Okay. Now, there is the dilute acid. I am adding it here. Check that the density of the precipitates are decreasing. That is, our objective is that the PPT is dissolved or not. Okay. You can see that only the volume is increasing, but the PPT remains unaltered. No change in the PPT. So, it is confirmed that sulfate is present, but there is no dry test for sulfate. So, for anion it will be easier that in anion section you will absent in the dry test section, that is in dilute sulfuric acid test, nitrate, acetate, sulfite, carbonate, these are absent. In concentrate sulfuric acid test, these are absent, and then you will move to the test for sulfate. Okay. So, test for sulfate done. Next one is the group separation. Okay. Now, there are some individual tests for the radical, that is for iron. For iron, it is using ferrocyanide, it is giving a Prussian blue PPT. Then test for cation. For zinc, it is a bluish white type PPT using the same reagent. Okay, so for iron, for zinc, etc., there is the same color, and also the copper, that is using the ferrocyanide. Copper gives chocolate brown colored PPT, but copper carbonate or copper acetate, these are maybe used as a sample. Now, first test for cation, that is we will use the group separation. So, dilute H2SO4 HCl, the group 1, then in presence of dilute HCl, that is H2S. But H2S in the second group, what is present? In the second group, what are the cations present? Tell me what are the cations present in the second group? Group 2. You can do it. What are the cations present in group 2? Only copper. There is also lead, copper. Okay. Next, for group 3, that is OS plus NH4Cl first, and then NH4OH. Okay. There is the PPT of aluminium or iron, anyone may be present. Next, group 4, OS plus ammonium chloride, ammonium hydroxide plus H2S. Okay. So, H2S is prepared in the in a separate apparatus, that is called Kipps apparatus. Okay. Kipps apparatus, where the H2S is gas is ready by using the reaction of iron sulfide and H2SO4. Okay. So, this is group 4. In group 4, cobalt, manganese, zinc, nickel. So, this is group 4. Next, group 5, ammonium chloride, ammonium hydroxide plus ammonium carbonate. What are the cations present here? Calcium, barium, strontium. Okay. And in group 5, group 6, there is only magnesium, that is NH4Cl, NH4OH, and then you can use sodium oxalate or disodium hydrogen phosphate. We will use Na2HPO4, disodium hydrogen phosphate, to present magnesium. This is only one radical. So, if after the completion of these tests no precipitates are found, then one radicals, that is cation, that is ammonium cation, NH4 plus. So, NH4 plus gives a confirmative test in dry way also, that is using sodium hydroxide pellet, and after using the issuing gas, that after rubbing the original solution with the NaOH gas, the NaOH pellet, then the issuing gas having a characteristic smell, which when held over HCl vapor, it gives a condensed fume. This is a special characteristics, and if you use the concentrated NaOH solution, then it will gives a different test. They are having a special test, that is using Nessler reagent. Okay. So, NH4 plus ammonium cation can be identified separately out of this qualitative, that is the group analysis. Okay. So, as I know that the sample is ammonium taken here, so I am doing first the ammonium test. So, you will also do the test for ammonium first, because if it is present, then you can confirm it before going to the group separation. Okay. So, the test for ammonium. Now, you just can see the color change, but you do not take the smell of the sample. So, only the color changing experiments will be seen here. Okay. So, just see at the experiment. Solutions taken, and I will add here NaOH pellet, that is solid sodium hydroxide. Okay. So, adding sodium hydroxide to that solution, no change till now, but a smell of ammonia is coming out from the test tube. Next one is the addition of Nessler reagent, K2HgI4. That is a mercury compound. Okay. So, you can see that a brown colored PPT formed. Okay. A brown colored PPT formed. This is also a compound. This is also a mercury compound. So, this confirms that the sample taken, it contains ammonium as a cation. So, when you will write, the problem is there, when you will write in the experiment observation inference in the continuation section. So, you will write dilute HCl, no PPT, group 1 absent, doing at last, that is group 6 absent. After that, you will write the sample plus NaOH solution plus Nessler reagent, a brown color PPT formed, and when you will do it, then you will also do at the dry test section, that is sample plus solid NaOH pellet, and take the smell is of ammonia. Okay. So, in these two experiments, that is first of all in the dry test, and this is the wet test, that is NaOH solution plus K2HgI4, the brown color PPT. This is also the confirmative test for the ammonia. So, as the cation we will get the ammonium, and anion earlier detected, it is sulfate. So, the probable composition is ammonium sulfate. Okay. So, today another one unknown sample, this is a very simple sample, was detected, that is ammonium sulfate. Understood everyone?